Okay, in this part, let's see how differentiability and continuity are related, because their relationship is a little interesting. So let's look at the graph of this. So right on this graph, is it continuous at x equals 4? Well, hopefully everybody said, no, it's not. That's where you have a vertical asymptote. So is it differentiable at x equals 4? And hopefully everybody said, no, it's not. And you're right. It's got a big old vertical asymptote. So at a vertical asymptote, it shouldn't be continuous and it shouldn't be differentiable. So if a function isn't continuous at a point, then it's not differentiable at that same point. We can also say that if a function is differentiable at a point, then it is continuous at the same point. This is called the contrapositive of the original statement. For those of you who took high school geometry, maybe you remember that word. That's just kind of FYI. All right, let's look at this graph. So is it continuous at x equals 4? Yeah. There's no holes, vertical asymptotes. It's continuous there. Is it differentiable at x equals 4? Well, no. Dun dun dun. Well, that's weird, but think of the definition of the derivative and what needs to occur for that limit to exist. So the definition of the derivative, that was that limit stuff. Well, in order for a limit to exist, the left limit had to equal the right limit. Well, when we start talking about derivatives, that would mean that the left slope equals the right slope. And let's look at this curve. So on the left of 4, you've got a positive slope. But on the right of 4, you have a negative slope. So your limits are equaling two different values, which means that the limit does not exist, which means that the derivative does not exist. So visually, limit or derivatives do not exist when there is a vertical asymptote, so something like that, or where there's like a sharp point on that curve. So something like this, like absolute value, it could be like that, or it's like a cusp. So derivatives do not exist at those sharp points. So differentiability implies continuity. So if it's differentiable at x equals c, then f is continuous at x equals c. However, it doesn't work the other way around. Continuity does not imply differentiability. Okay, so that is actually going to do it for 3.1. Actually, I thought I had a little bit more to do in that section, but I don't. So give the homework a try, and just keep trying. Don't be, discouraged if you're like, oh my gosh, these things are not working out. It's okay to struggle a little bit, especially in the beginning. Just keep trying, just keep asking questions, and you will be able to do this stuff. It's not impossible, even if it seems like it is. I will say, some of these are a little bit tedious because there's a lot of algebra involved, but hang in there. Don't give up. Just keep going. Just keep trying them out. Okay, so good luck, and let me know if you have questions.